Here's problem 6.5. A highway curve has a radius of 0.14 kilometers and is unbanked. A car weighing 12 kilonewtons goes around the curve at a speed of 24 meters per second without slipping. What is the magnitude of the horizontal force of the road on the car? Let's take a bird's eye view of what's going on here. The car is going around in a horizontal circle, and we're looking at the car from up above. It's going around this circle, and it's going at constant speed, so there's no acceleration in its forward direction. But since it's going around the circle, there has to be a centripetal acceleration, and because of that centripetal acceleration, which will be towards the center of this circle, there must be a centripetal force. So we have a centripetal force on this car towards the center of this circle. And in this case, that force will have to be supplied by the force of friction. Friction on the tires, on the side of the tires, static friction in this case, because it's not really moving in the radial direction. That will be the force that supplies the centripetal force. So the way we would describe this is we'd say the summation of all the forces in the direction of acceleration is equal to mass times acceleration, centripetal in this case, and that's equal to the net force in that radial direction, which actually is just the force of friction. So we'd write this as mass times the centripetal acceleration, v squared over r, is equal to the force of friction, which would be mu times mg in this case, mg being equal to the normal force. And this would be equal to the frictional force. But let's look at what is being asked in the problem. It says, what is the magnitude of the horizontal force of the road on the car? That horizontal force is indeed the frictional force. Now we don't know what that is because we weren't given the coefficient of friction on this road. But we can figure out the resultant force, and in this case, that resultant force is physically supplied only by friction. There's no other force in the horizontal direction in this particular problem. So all we need to do is find the resultant force, and that will be our frictional force. So friction will equal mass times acceleration in this case, and that's going to equal, we have car was weighing 12 kilonewtons, so that's a little bit of a problem. We have to figure out what the mass is. So the weight of the car is mg. The mass will be the weight divided by g, which would be 12,000 newtons divided by 9.8, and that will give us the mass. 12,000 divided by 9.8 is 1,224.5 kilograms. So going back to this is going to be 1,224.5 kilograms times the velocity, which is 24 meters per second squared, over the radius of curvature, which is 140 meters, 0.14 kilometers. So that will be our frictional force. That times 24 squared divided by 140 is 5,037.9. So we'll say 5,038 newtons. That is the frictional force, that is the net force, that is the centripetal force in this case. They're all the same. And that is the horizontal force of the road on the car.